Hi viewers, whether I'm audible ma, just post a message ma. Whether am I audible to you all, guys? Am I audible, guys?
Guys,
Am I audible, guys? Am I audible? Viewers, am I audible to you? Thank you all. So shall we start with the session ma? We are already running out of time, so I'll straight away go into the session. If any issues, na just kindly ping me a message or make a call to me, so that I would know. Okay. So just a moment, I'll increase the volume. So good evening all. This is like a session just prior to your any examination on unit 1 of your DPSD digital principal system design. Simply speaking, in some of the colleges they used to call it or tag with a course name of digital electronics. So this unit 1 which we are going to discuss is a common unit for any CSE students or any department students. So I hope this would be useful for you guys when if you are preparing for any of your test this week. So as you all know, this is your unit 1 named Boolean algebra and logic gates. So here I have come with few problems, a kind of problems what could be asked in your examinations. Like as you all know, in your unit 1, first comes is the number system. Under number systems, you should know all the 12 conversions. So the types of number systems. What are the types of number systems? Like you have octal, hexadecimal, binary, and decimal, right? So these are the four number systems and the conversions among them. So it will give you 12 conversions. Along with this, you should be clear with your De Morgan's theorem, consensus theorem, transposition theorems. So three theorems, 12 conversions, right? And also you should be clear with your 12 postulates, Boolean postulates, like you have formulas. You would be thinking a dot 0 is equal to 0, a plus 0 is equal to a. So these are the postulates. Postulates are nothing but without proof. If you have any laws or rules, that we call it as the axioms or postulates. If you have a proof now, we call it as a theorem. Okay. And so in your unit 1 under the topic number system, you should be aware of your 12 conversions, 12 postulates, 3 theorems, and 3 properties: associative property, distributive property, and commutative properties. So these are the things you should get to know, and most probably they will ask only in part A questions. And using this only you can solve the part B questions. So which I'm going to quote for both part A and part B. Got it? So topics involving in all these things. And next comes is your logic gates. All the basic gates you should be able to identify and or not, and your universal gates like NAND, NOR, not NAND, NOR, and your special derived gates XOR, XNOR. Okay, with all the functions, truth table, switching circuits, and the pin diagrams of it. So which would help you out. And next comes using the laws and theorems. How could you simplify an expression? This is one way of reducing an expression, logical expression. And secondly, using K-map, Karna mapping method, and third, tabulation method. As far as your syllabus is concerned, tabulation method is not included, so I'll stop with your K-map problems. So we are going to solve around 10 to 15 problems based on these things. It would be helpful for you, I hope. So with this note, I'm going to start. Okay. So suppose your very first problem is going to be like convert some value is given. What is that value? 4321, and it was given with a radix value of what? 8. 8 means what? Octal. So they are asking you to convert a octal value into a hexa, because with the empty brackets you have a 16, base value 16. So this clearly states that you have to come out with a converted value of your hexadecimal. So first, what is the steps? Just a minute. So here, what is the given value to you? The given value is, octal value is 4321, and which they are asking you to convert it into hexadecimal. As you all know, I have stated already in your sessions and classes, online sessions, as well as in your offline mode classes, always you can't convert directly any octal to hexa or hexa to octal. First you have to convert it into a binary, and thereafter you have to convert it into the required one. So step 1 is what? You have to convert it into binary. What are the given values? And that too, it is in the base of 8. So base 8 now, if you want to represent in binary value now, with 3 digits you can go for, or 3 bits, right? 3 bits. If you want to symbolize one digit, you have to make use of 3 bits. Say suppose 4 now, I could write it as 100. 3 na 011, and 2 na 010, 1 na 001. So now I have converted the given decimal value, that is in terms of the decimal. Why am I making use of the word decimal? Though it is an octal value, here the digits are which we know, like we human beings know in terms of like 0 to 9. So these together will constitute whatever the to the base value they have given. Okay. So 4, 3, 2, 1 in terms of binary, na, and that too in octal. Here the given value is what? Octal. Octal, na, you can denote or represent any digit of octal value with the help of 3 bits. That I have done. Okay. Next, step 2. What I want is exactly a hexadecimal. Hexana, you have to group the given value in terms of 4 bits, starting from your right hand side to your left hand side. Got it? From the, in other words, from LSB bit to, from LSB bit to MSB bit, you have to group the bits in terms of 4. Like 1, 0, 0, 0, then 1, 0, 1, 1, then finally you have 1, 0, 0. So now what is the value? Now I have grouped it into 4. So the binary which I have grouped in 4 will give you the hexa value. So what is the hexa value of this? This is 1, this is 13. 13 means what? Which is equivalent to A is 10, B is 11, C is 12, D is 13. So this is what? 13. 13 na D. So this is 8. So what is the hexadecimal value I have obtained out of conversion na 81. So this is the, so through your 2 steps you can obtain your hexadecimal value from your octal. Did you get it? So this is one kind of problem you could face. And the next question could be like, they would ask you to convert a given octal value to a binary. Binary na, only step 1 has to be performed. Here to obtain hexa we performed one more step, whereas here they are asking you to convert just into a binary, which is very easy, right? So for this, just merely do the step 1 alone. What is that? You have to represent all the digits with help of 3 bits. What is the 3 bits? 6 na 110, 2 na 010, 7 na 111. Okay? So now you have to write the answer properly like this with a base value. So the base value is very important. You have to mention the base value. Okay? So this is one more problem we have seen. I hope you would have understood. So we could move to the next problem. Next problem here is what? Subtract a problem. The third problem. What is that? Subtract 748 from 963. So from 963 we have to subtract 748 using tens complement. Tens complement is nothing but 9's plus 1. So what is 9's complement? Always the subtrahend. That is what? What is that? 748. So it should be subtracted with how many of a number or the how many of a digits we have with those many values of 9. Since I have 3 digits, I have to subtract with 748. So I'm going to subtract that so as to obtain first the 9's complement. So 9 minus 8 is what? 1. 9 minus 4 is 5. 9 minus 7 is 2. So I have obtained the, so what is the step 1? I have obtained the, what is the step 1? I have obtained the 9's complement of 748. Now after that I have to add plus 1 so as to get what? The 10's complement. So this is the 10's complement of 748. This is the 10's complement of 748. So now after taking the complements, always I've told you complements, why, what is the use of complements? Now it will help you to perform the subtractions using adder, right? Adder circuit. So first we will take the complements, we will finish off the complements, and then thereafter whatever the values we have obtained, with that value we are going to just add it. So what is that? 963 plus what is the tens complement of 748? Actually first they asked to subtract. Instead of performing the logical subtraction, I'm going to perform a logical addition of the tens complement of the given value of subtrahend. What is that? 252. So now add these two, I will get, okay? Did you get it what I'm trying to say? And also you know very well that I have already stated the conditions to perform 1's complement, 2's complement, 9's and 10's. While doing so, if you have a carry, this is a carry while I'm adding. I have 3 bits to get added with the another 3 bits or the 3 digits. So while doing so, I should have only 3 digits of output, where I'm having an extra bit, and that too in the MSB. So that would be contributing for your carry. If a carry is generated, then what is the condition in tens complement? Ignore. If carry generated na, discard. If carry generated na, discard carry or ignore the carry generated. Discard carry. So if you discard the carry, what is the final answer? Answer is 215. Did you get it? So this is the answer of 963 minus 748. Also if you do the direct subtraction, you will get the same value. If you want, you can check. Okay? Did you get it what I'm trying to say? If it's a 9's complement, na, then if say suppose if you are doing like this and they are asked you to do using the 9's complement, na, if a carry is generated, that has to be added again. So that we call it as a end around carry. Wherein here for this problem, it is a tens complement. So using tens complement, if a carry is generated, always discard or ignore it. Okay, and take the remaining digits alone. So this is the answer. Did you get it? Okay, fine. So now we are going to do the next set of problems. So these are the kind of subtractions, conversions you could see, right? So now coming to your next problem. What is the next problem now? Express a Boolean expression y is equal to a plus b bar c in canonical SOP form. Express, they are not asking you to reduce. They are just merely asking you to express a given expression. Already it has been expressed in some form, but they are asking you to express again in a canonical SOP, that is in the standard form. What that means? All the minterms should contain all the literals. All the literals, na, the other word is what? All the variables. Here A is a variable. A only alone is there, wherein B and C is not available. Here A is missing. B and C is available. So all the minterms, this is one minterm, this is one minterm. So all the minterms should have all the variables of the function y. So take the problem. So y is equal to a plus b bar c, wherein it is already in SOP form. So only thing you have to do is whichever is missing, here B and C. So B plus B bar. So if I do A into 1, the value of this variable is going to change? No. So into 1 na, B plus B bar. So how many other times if I put into 1, those many times I'm going to get the same value a. A into 1 of anything is again A the. Instead of 1, what is B plus B bar, the postulate or the rule? Rule is what? Since the rule or the postulate A plus A bar is equal to 1, I'm going to take that rule and I'm going to apply here. That is what I'm doing. Instead of 1, we are putting it as a B plus B, whichever variable is missing. Here B and C. So instead of that, B plus B bar, C plus B bar into. Then plus here in the next minterm, A is missing. A plus A bar, then B bar, then C. Now multiply and simplify. So here you have two times you have to do. The steps will be long enough. So instead you do it in a shortcut method, like A into B into C. That is one term. Then A into B into C bar. Then A into B bar C. Then A into B bar C bar. Did you understand what I'm doing? I'm having this to be constant for the first multiplication of this. First I multiplied A into B into C, then A into B with the C bar. Then I started with B bar. So A into B bar C, then A into B bar C bar. Did you get it? How I got it in one step? So this is how. Next, this is only one variable, so we could just simply write it as A B bar C plus A bar B bar C. So here whichever terms repeating again, you can neglect A B C, no, A B C bar, no, A B bar C, yes, here once again repeating, other than that nothing. So simply I could rewrite it as in SOP form, that too in min terms, 7, 6, 5, 4, 1. How am I writing? With the help of the code, because 3 bit na, or 3-bit variable na, then the code is 421. If it's 4-bit na, 8. If it's 5-bit na, 16. So since I have 421 A B C na, that means values are, if they are not complemented, the values are 1. If they are complemented, that means the variables carrying a value of 0 in SOP form. Okay, so this is the answer for express the Boolean expression y is equal to a plus b bar c in canonical. So this This is how I have brought it in a canonical. And do remember, only when the expression in canonical form you can perform any simplification method like K-map or tabulation. Okay, for that purpose only you need this conversion to be important. Okay, you might be thinking why SOP and POS is so that important. Now, this is the reason for simplification purpose. Next problem, reduce the following Boolean expressions. So this is where we are going to deal with your problems like simplifications. For this, I hope the equations are visible to you. Is so far am I good with the explanations, or should I change the way I speak, or I have to be louder? Students, am I good with the explanations or have to change it? Kindly let me know. Am I audible now? At least? Thank you, thank you. I'll carry on with that. Thank you, ma'am. So now coming to your first problem for reduce the Boolean expression. So this is one such expressions where you could see the variables involving. Here you could also notice they didn't give the function name. This is speaking about one function. They didn't give f is equal to or y is equal to. So on your own you can assign anything. Some people will start with f is equal to or y is equal to. You can give any variable other than these variables contributing for function. Got it? So f is, I'm assigning it to be f is equal to a bar c bar plus abc plus AC bar plus AB bar. Okay. So do you people have any idea how could you reduce this? Could you make a try at least? If you're having a notebook, you can have and sit and try on that also. Or you can give me a hint which variable could be taken out first. So simplification of any expression, just you have to rearrange the terms. You can try seeing your rules and your postulates, your theorems, your properties. Okay. So as far as my vision, what I could see is immediately these two terms are picking my eyes. Like I could take C bar out common, then I can have A bar plus A and ABC plus AB bar. Step by step you have to do it if it's for 8 or 4 marks now. So A plus A bar will give you 1. So applying the rule or the postulates A plus A bar is equal to 1, we can simplify this step with this rule. And you have to mention that since A plus A bar, you have to mention the rules, only then you can score your marks. So sorry, here I left ABC. ABC plus AB bar, then here also ABC plus, and thereafter again what you have to do? Any other further reductions could be done? Think and tell me, because here only C bar is there and plus ABC plus AB bar. Even if I am going to take A common, could I do anything? If I take A common, again you will have BC plus B bar. BC plus B bar, you can't apply any rule. So here you have to choose the distributive law. Only few problems will make use of this. So you have to rearrange and write these two terms. You have to apply the distributive law over these two minterms. What distributive law is nothing but you have to imagine that C bar plus ABC plus AB bar. You have to imagine it in this way. I actually speaking, if I want to take anything common, could I take it as such? No, I couldn't take it anything common. But converting these two min terms into POS terms, I could convert a SOP term into POS term if I apply distributive law. That is what the use of distributive law. So how could I do that now? This is what A into B into C, right? So if I give, because already I have a rule, C plus C bar is equal to 1. So what I can do is C bar plus AB, once I could write it, because this is into, no, so I can rewrite C bar plus C. Did you get it what I am trying to say? You have to think AB as one term and the other like this. Got it? So anyway, if you group it, you will have the same value. That is what the distributive law. So now applying the rule C plus C bar, you will have 1. So this becomes the value 1 and I have AB bar, then C bar plus AB. Did you get it? Now multiply, you will have, I'll continue here, continue. So this is C bar plus AB plus AB bar, which could be rewritten as AB plus AB bar plus C bar, which is already in SOP form. Just you have to remove the brackets alone. So what is A and AB bar? You can take your A common and you can have the rule to be applied B plus B bar plus C bar. So again here also A into 1 plus C bar. So what is the answer? A plus C bar is the simplified expression of this problem, first problem. Did you get it? How we are getting it? You have to imagine that ABC, you have to apply the distributive law. That is, what is distributive law? The way you group it will give you the same answer for both LHS and RHS. That is, AB of C is equal to A of BC, which is nothing but ABC, right? So here we are splitting the multiplication or the product term and then we are adding with C bar. That's it. Simple mathematical expression. Okay. So now I hope you would have understood, but once again you have to sit and do it. You please try this problem on your own. Okay. Next problem is what? X bar, Y, Z. So I will do that in the next sheet. So what is the next problem now? F is equal to x bar y z plus x z plus x bar z. So how could you simplify this? Very simple. That here you have x bar y z, here you have x bar z. So take out the common x bar z. So you will have, so I am clubbing these two terms. Okay. So y plus 1 plus xz. So you will have x bar z into 1 plus xz, which is again x bar z plus xz, which is again z could be taken out common. You will have x plus x bar, or for all the steps you have to write, since x plus x bar is equal to 1 and 1 plus y is equal to 1. Okay, all these are marked always in your examination. So see, this one we will have final answer to be Z. So the simplified expression of this function f is equal to the three product terms could be written or could be carried away just by the literal Z. Did you get it? So kindly try doing it once again on your own. That's what I could advise you. So these kind of problems could be asked for 8 marks, things like that. And that too, the first problem, which involves so many steps, no, probably in 8 marks. So now coming for the next problem, subtract a given binary value of 5-bit from a given value of 6-bit of binary using 2's complement method. You all know subtraction could be performed with the addition operation if you apply any complement method. So here they are asking you to, already you did a 9's complement, 9's and 10's complement. For your kind information, it is a decimal involved. Did you get it? Here 1's complement could be done using or could be done over the binary subtractions or additions. So binary values, subtraction of your binary values could be done with the help of 1's and 2's complement. If it's a 9th and 10th complement, that is a BCD arithmetic addition. Got it? So now coming for this, subtract some value. That is, what is this value? I have written it over here. This value from this. So that means what? This is the minuend and this becomes your subtrahend. So this is your subtrahend, this is your minuend. So minuend value is what? This is the binary. It is in the form of binary. What is the decimal value now? 47. What is the decimal value of the subtrahend now? It is of 27. Got it? I know, I hope how you could find out this. I hope you know. Because 11011 means what? This is 8421. Next bit is what? 16. So what is the value? 16 plus 8 is 24, 25, 26, 27. So this is how I'm telling you this is 27. So similarly 47 now. So 16 is 0 here, 16th bit. So 32, 32 plus 15. 32 plus 15 is what? All these value will together, added together will give you 15. So 32 plus 15 is what? 47. Did you get it? So this is how I'm straight away writing that's 47 minus 27. Here look at this. You might have a question. Usually to subtract a lower value, that is to subtract a higher value from a lower value, we mostly only at that time we will opt for complements, 1's complement or 2's complement, because the numbers would be ended up with subtraction, they'll involve a borrow and all. Wherein here, look at the problem, they are given a higher value. So you were asked to subtract a lower value from a higher value, which is a very normal subtraction. So here decimal value will give you 47 minus 27, it is 20. Binary also, if you perform direct subtraction, 1 minus 1 is 0. Here also 1 minus 1 0, 1 minus 0 is 1, 1 minus 1 is 0, 0 minus 1 now we have to borrow. So here you have 1, so 10 minus 1 is what? 1. So this is your normal subtracted binary value. You are getting it obviously, and this is a decimal value. But the question is, you are asked to do this, perform this using 2's complement. So what is the method? As you all know, minuend has to be kept as such. What is that? Value 47, binary value of 47. Whereas you have to apply always 2's complement only to the subtrahend. So this is the subtrahend, 2's complement. So look at the minuend. It has 6 bits. So make the 5-bit to a 6-bit first. So for that what you have to do? Add 0. Add 0 to the front MSB bit. So 0, 1, 1, 0, 1, 1 is the form of binary. You have to take it for 27 to perform 2's complement. So 2's complement, first you have to perform 1's complement, invert 1's to 0s and 0s to 1's, and then add 1. You will get 2's complement of the value 27. Then add that binary value with the 47. So while I'm doing so, I got a carry to be generated at the MSB bit. Since you know for 2's complement, if you have carry to be generated, as like your tens, you have to ignore or discard carry. So therefore, the remaining value speaks about what is the answer. Here, what is the answer? The answer, actual answer starts with 0. So the MSB bit is with 0. 0 means positive value. So remaining gives the value of the subtraction or the addition. So 10100. What is that? This is what I have got during normal subtraction also. So both are right. So this is how you have to write the answer. I hope you people would have understood. So kindly go through when the video gets saved again. Next problem. Convert a decimal value to binary. Always, you know that very well. Successive division will give you the binary of 62. The integer value 62. So this is the integer part. This is the fractional part. Just a minute. This is the integer part and this is your fractional part. So for integer part, always you have to go for your successive division or double dapping method. They call it as double dapping method. Successive division, you have to take the integer divided again because they are asking for binary. So they, if binary na the base value, so divide many, how many ever times you want to divide it, but only with a binary value. What is the base value of binary? 2. So 2 divided by 62. It will, quotient is what? 31. Remainder is what? 0. Nothing. No remainder. So again try to divide it. You will have 15 times to be going off and you will have one remainder. Again 7 twos are 14, remainder 1, and here also 3 twos are 6, remainder 1, and again